There is a very specific universal feeling of dread that hits when you open up a certain drawer in your house. You know the one I'm talking about.
Oh, yeah, the junk drawer.
Right. But specifically the drawer filled with tangled electronic cables. Like you've got your old phone chargers, a random HDMI cable, some, I don't know, weird proprietary wire from a digital camera you literally haven't seen since 2015.
And you just need one thing.
Exactly. You reach in to grab just one specific charger, and the entire knotted mass just comes up with it. It's an absolute unmanageable mess.
It really is.
So, okay, let's unpack this, because today we're going to talk about the exact digital equivalent of that drawer, and more importantly, the incredibly satisfying art of untangling it.
Yes, the best part.
Welcome to the Deep Dive. Today, our mission is to explore the philosophy of refining complex systems. And we're looking at this through a highly specific lens today, which is a personal journal from a software developer.
Right, so the source material we are dissecting today is a blog post dated May 5, 2026. It's written by a developer who goes by the name Ang. And the post is titled Notes on Haskell Programming, Part 127, From Nested Case Block to Decoupled Function.
Now, I want to say right out of the gate to you listening, if the phrase Haskell Programming just made your eyes glaze over, do not tune out.
Please don't.
Yeah, you absolutely do not need to be a coder to appreciate what we're digging into today. Because while the terminology is, specific to software engineering, the mission here is completely universal.
Right, it applies to everything.
It's about the process of taking something tangled, messy, hard to understand, and step by step transforming it into something elegant, modular, and just crystal clear.
And we should probably clarify upfront that this isn't a deep dive about writing code that simply works. Like Ang's code at the very start of this journal entry, it already functions perfectly.
It already does the job.
Exactly. It executes the task it was built to do.
Yep.
What we are really looking at here is the art of refactoring. And refactoring is the process of restructuring existing code without changing its external behavior.
Right.
We do it to reduce cognitive load. Because when a system, and whether that's a piece of software, the workflow of a small business, or even just, how you organize your physical desk when it gets too complex, it drains your mental energy just to navigate it.
It's exhausting.
It is. And Ang's journal is essentially a masterclass in systematically reducing that cognitive load.
And Ang actually hints at the real villain of this story very early on. Like before we even get into the step-by-step cleanup, we see that this piece of code is dragging around a massive, heavy boulder.
A huge one.
Yeah, it's a huge data structure called ARGS, A-R-G-S, and it contains a ton of bloated information about file formats, original pathways, user inputs, all that stuff.
Way too much information.
Right, and the code we're looking at is forced to carry this boulder up a hill every single time it runs, even though it doesn't need most of it. But we'll get to that climax a little later. So where do you even start when faced with a system that has just spiraled out of control?
Well, you have to open that drawer and pull out the biggest, ugliest clump of wires first.
Yep.
Ang begins by addressing a piece of logic that had become trapped inside what developers call a nested case block.
Which sounds intimidating, but it's really not.
No, you can basically think of this as a series of conditional statements layered inside one another. Like, if this happens, check that. But if that happens, check this other thing.
It's just a giant chain of what-ifs.
Exactly. And over time, as a program grows, developers tend to just slap new rules inside existing rules. It's that just one more thing syndrome. And it creates a deeply indented, incredibly fragile web of logic.
And so Ang's first move to fix this is a technique called code-to-method extraction.
Right.
Which, going back to our drawer of tangled cords, method extraction is basically like pulling one specific charging cable out of the knot, untangling it completely, and laying it flat on the table.
Isolating it.
Isolating it, exactly. So you can actually look at it and say, okay, this piece right here is just the logic that opens a generated ebook. Ang isolates it and gives it its own standalone function named open ebook.
But as Ang does this, we run into a highly specific kind of wild quirk about the Haskell programming language.
Oh yeah, this blew my mind.
Right. Ang notes that during this extraction, indentation is strictly enforced. The variables CMD and CMDArgs, which just stand for the command and the arguments being run, they must perfectly align visually on the screen with a variable out path.
Because they are all defined within the same local scope of what's called a let block.
Yeah. And what's fascinating here is how the Haskell compiler fundamentally interprets the text you write. In many popular programming languages, the computer doesn't care about spaces or new lines at all.
It just ignores them.
Exactly. You could write an entire program on one massive scrolling line of text. And as long as you use the right punctuation, like semicolons and brackets, the computer understands it perfectly. But Haskell takes a completely different philosophical approach.
It cares about the spaces?
It cares a lot. The Haskell compiler actually uses the white space on the screen to understand the logic of your program.
So if you just hit the space bar, like one too many times,
The whole thing breaks.
that is wild.
It is. If CMD and CMDargs are moved to a different indentation level, the compiler assumes you are simply continuing the definition of outpath from the line above.
It thinks it's all one sentence.
Right. It tries to read it as one continuous thought, gets confused, and throws a syntax error. And the language designers did this intentionally to enforce visual discipline.
Oh, to force you to be neat.
Exactly. In other languages, you can have a terrifying mismatch between how code visually looks to a human and how it executes for a computer. You might think a piece of logic is nested because you manually indented it, but the computer reads it completely differently.
So Haskell just eliminates that danger entirely.
Right. The structure of the logic must be reflected perfectly in the visual layout of the text. You literally cannot write messy-looking code that works.
That is intensely unforgiving.
It definitely forces you to keep your room clean, so to speak.
Okay, so we've pulled the cable out of the drawer, and it's laid out straight. But, just physically isolating a piece of code doesn't magically make it easy for a human being to understand.
No, not at all.
We have to pivot from the physical structure of the code to the psychological structure of reading it. Like, how does the human brain actually process this information?
And this is a crucial transition in the journal. Ang states that the next refactoring step moves away from a script-like function to a more modular and declarative style.
Okay, so how does that work in practice?
To achieve this, Ang takes the specific gritty details about how different operating systems open files, like how a Mac uses the open command versus how Windows might use something else, and extracts that into another standalone helper function named getOpenCommand. And structurally, Ang moves the logic out of a let block and down into a where clause.
Okay, so what does this all mean? I'm going to push back a little bit here on Ang's behalf, actually.
Sure, go ahead.
If the computer reads this code and executes the exact same underlying commands, whether the programmer uses a let block or a where clause, why bother spending the time moving it around?
That's a fair question.
Like, if the output is identical, isn't this just aesthetic window dressing? It feels like spending 20 minutes rearranging the furniture in a house nobody else is going to visit.
Well, it is much deeper than rearranging furniture because the way code is organized dictates how much mental energy it costs to modify it later.
Okay.
Using a where clause for helper functions fundamentally changes the reading experience by separating the what from the how.
The what from the how.
Right. In a let block, which is more script-like or imperative, you are defining all your variables and temporary steps first before you finally get to the main action. You're forcing the reader to hold a dozen puzzle pieces in their working memory before you show them the picture on the box.
Okay, so it's like someone telling you a story by describing the engine mechanics of a car for 10 minutes, detailing the spark plugs and the fuel injection before finally mentioning they drove to the grocery store.
That is a perfect analogy. Yes. A where clause flips that dynamic entirely. It's declarative. It allows the programmer to state the main intention at the very top of the function.
You just declare what you're doing right away.
Immediately. Then below that, in the where clause, you tuck away the granular OS-specific implementation details the how. When another developer reads that code, they instantly grasp the intention without getting bogged down in the mechanics.
That makes a lot of sense.
And Ang also pairs this with type signatures, which explicitly state what kind of data goes into the function and what comes out. Those aren't just polite comments, they are enforced contracts that act as unignorable documentation.
So the structure makes total psychological sense now. We have a clear label on our cable, the what and the how are separated. But as we look at the next entry in Ang's journal, we notice there is still friction in how these newly separated pieces are actually communicating with each other.
Right, the handoff is messy.
Exactly.
Ew.
Which brings us to the introduction of a little function with a very strange name, which is uncurry.
Yes, uncurry. To understand the problem uncurry solves, we have to look at what that helper function, getOpenCommand, is actually handing back to the main program. It returns something called a tuple. Conceptually, a tuple is a way of taking multiple distinct items and shrink-wrapping them together into a single, indivisible package. In this case, the package contains a string of text and a list of strings.
Right, so the helper function goes off, figures out we are on a Mac, and comes back carrying this shrink-wrapped package. Inside that package is the word open and the file path.
Exactly.
But the function that actually executes the final command, which is called call process, doesn't want a package.
Yeah.
It doesn't own a pair of scissors to cut the shrink wrap. It wants the items handed to it individually.
Right.
So wait, if we just type the word uncurry, does it just delete the variables and the computer guesses what goes where? Like, how does it magically fix this?
Well, it doesn't guess. It performs a very specific mathematical unpacking. Call process expects multiple separate arguments. Without uncurry, the programmer has to manually write out the instructions to break open the tuple, pull out the first item, assign it a temporary name like CMD, pull out the second item, assign it a temporary name like args, and then finally feed those named items into call process.
Oh, wow. Okay, here's where it gets really interesting because I'm visualizing this now.
Yeah.
Without uncurry, it's like arriving at a hotel, manually unpacking your suitcase, laying out a shirt and pants on the bed, staring at them to confirm they exist, and then finally putting them on.
Yes.
But using uncurry is like having a magical suitcase. You just throw the suitcase at the closet, and the mechanism inside unzips, perfectly dresses you in an instant, and leaves no trace that the suitcase ever existed.
That is exactly what it does.
It entirely eliminates the need for the programmer to create and manage those temporary variables.
And getting rid of temporary variables is one of the most vital things you can do to reduce the burden of state in a program. Ang provides a direct comparison in the journal.
Yeah, I'm looking at it.
Without uncurry, the code looks like this. Let cmd args equal get open command out path in call process cmd args.
It's just wordy. It feels really clunky.
It is clunky, and it introduces a massive cognitive burden because of that in keyword. In Haskell, this specific block is called an expression. The compiler explicitly needs that in keyword to act as a strict boundary.
To fence it in.
Exactly. It tells the compiler the temporary variables CMD and args only exist inside this specific execution.
It's like filling out a bureaucratic form in triplicate, just to define where a temporary thought begins and ends.
Truly.
But why does the compiler care so much about temporary variables in the first place?
Because tracking state, like remembering what variables exist, what their current values are, and when they should be deleted, consumes memory and introduces risk. Every time you declare a temporary variable, you are creating a new ball that you have to juggle.
You could drop it.
Right. If a programmer accidentally uses the wrong variable name later or forgets to clear it, you get bugs. It's the burden of state.
Wow.
By writing uncurry call process, get open command out path, Ang sidesteps the let, sidesteps the in, and completely avoids naming things that only need to exist for a microsecond anyway. The logic becomes pure and direct.
It is so incredibly satisfying when you can just delete words and the thing actually works better.
It's the best feeling.
So, okay, the syntax is cleaned up, the data is flowing smoothly without temporary baggage, but here is the massive plot twist in Ang's journal.
Here we go.
The absolute peak of this refactoring mountain isn't actually about writing better code at all. It's about realizing you don't need half the data you thought you did.
This is the moment we move from syntax optimization to pure architectural philosophy.
In this final step, Ang takes a hard look at the open ebook function and realizes it is doing way too much work. Originally, this function was taking the user's raw input, calculating what the final output file name should be by utilizing tools like replace extension and manipulating text into lowercase, and then finally opening the file.
A lot of steps.
Ang decides to remove the responsibility of generating the final output file name from this function entirely. That job is shifted somewhere else in the broader program, to the specific code that actually generates the ebook in the first place.
And that single decision resolves the core underlying problem we hinted at earlier. If we connect this to the bigger picture, Ang is applying two of the most critical concepts in systems design: single responsibility and loose coupling.
Because remember that villain we talked about, that massive boulder called args?
The giant data structure.
Yeah. The cascading effect of shifting responsibility is amazing to look at in the journal. Because Open eBook no longer calculates the file name, it no longer needs the replace extension tool, it no longer needs to map characters to lowercase, it no longer needs to import the whole system file path library.
It can just let it all go.
And most importantly, it no longer needs to carry that heavy args data type.
Right, and the function signature changes dramatically as a result. It goes from Open eBook takes args and outputs IO to simply Open eBook takes file path and outputs IO.
Can we actually break down that IO part real quick? Because to a non-programmer listening, that just looks like algebra.
Sure, yeah. IO essentially tells the system that this function isn't just doing invisible internal math. it is going to trigger a real-world action.
Like a physical result.
Exactly. In this case, opening an actual window on your operating system. So the new signature, file path to I/O, simply means give me a clean file path and I will perform the action of opening it. That's it.
It just takes a string of text and does an action. It finally dropped the boulder.
It did. And let's look at the catastrophic domino effects of tight coupling to understand why dropping that boulder is such a massive relief.
Okay.
Before, OpenEbook was tightly coupled to the args data structure. If another developer came along later and changed how args was structured, maybe, adding a new required field for a different part of the program, it could potentially break the OpenEbook function.
Even though OpenEbook doesn't even use that new field.
Exactly. It doesn't care about 90% of what's in args. It was burdened with unnecessary knowledge. Now, the function knows the bare minimum required to do its job. It doesn't know about file formats, relative paths, or user arguments. It receives a final, clean file path, and it opens it. Single responsibility.
It's incredibly elegant. I mean, it went from a tangled knot of logic, tightly bound to all this unrelated data, to a completely independent, cleanly labeled cable that just plugs in and does one thing perfectly.
And that makes the overarching system infinitely more robust. When components are loosely coupled like that, you can swap them out, upgrade them, or fix them without causing a devastating ripple effect of failures across the rest of your software.
So, bringing this all together for you listening, we've followed the journey of Aang's code from a messy, deeply fragile nested block to a pinnacle of modular design. We watched as Aang extracted the logic into an isolated space.
We saw the psychological shift, too.
Right? Hiding the complex how behind a declarative where clause.
Yeah.
So the intention was immediately obvious to any human reading it. We dug into the magic of uncurry, which automatically unpacked data and stripped away the dangerous, bureaucratic clutter of temporary variables.
Yes.
And finally, we witnessed the relief of loose coupling, where stripping away the heavy args data dependency left a function that was perfectly streamlined and just fiercely independent.
The real victory here is a journey from heavy complication to lightweight clarity.
Exactly. So the question is, what stands out to you? Like when you look at these hardcore software engineering concepts, how do they apply to your daily life? Where are the tangled, nested blocks in your own workflows?
You know, I think the most powerful takeaway here isn't just about dropping unnecessary tasks, but looking specifically at the concept of uncurry and how we handle temporary states, especially in human communication.
Oh, interesting.
Yeah, uncurry was beautiful because it allowed intent to pass directly to action without having to create temporary distracting variables. If you audit your own conversations, particularly difficult ones, how many conversational temporary variables do you create?
Oh, wow.
Right? How much time do you spend hedging, making excuses, or adding unnecessary context before you finally just state what you need? What if you applied uncurry to your own communication?
Just cut out the middleman.
Exactly. What if you stripped away the temporary clutter and simply passed your direct intent to the other person?
If we just untangled those conversations and handed over exactly what was needed, imagine how much lighter things would feel.
The clarity would be instant.
Something to think about next time you reach for a charging cable or try to explain a problem to a friend.